Greetings, this is Artie from Artifact Electronics. Here's the latest addition to my arcade game Horde. Picked this up from a local collector. It's a 1978 Atari Super Breakout. I've already started tearing it apart because it doesn't work. It's an okay shape. Cabinet has a bunch of dings on it. Looks like it's got a lot of kicking or water damage under the front panel. I've torn the monitor out. It's a black and white monitor with a color overlay. And I do have all the bits and pieces, all the marquee stuff and the bezels. So it is complete, but it doesn't work. When we turned it on, all it did was the light on the serve button lit up very faintly, but you couldn't coin it up, you couldn't play a game. The monitor was dead, except that the neckboard lit up. And that was about, or that's about where we are at. This game, or rather its predecessor, which was just called plain Breakout, in the same cabinet, same color scheme, looked pretty much the same. When I was an undergraduate, I saw this at the local arcade one day, and I played it, and I was totally blown away by it. Of course, I had to run home and try to program Breakout on my Radio Shack TRS-80 Model 1. Well, I programmed it in BASIC and the results were predictable. It was horrible. It ran slow, it flickered, it was unplayable. And I tried to figure out what it was I was doing wrong. Remember, no internet. I was in a small college town. Books were available, but they were all academic books and none of them really dealt with game design. But after a lot of bugging people and asking them questions and stuff like that, I finally figured out, all right, I got to write this in assembly language. Now, what is assembly language? I had no clue. So again, I did a lot of digging and I kind of got an idea of what assembly language was, but I had no idea of how to get the info on how to program a microprocessor. So I called up Mostech, which was the person or the company that made the Z80 processor in it, and said, could you send me some info on assembly language on your processor? And they said they'd be happy to oblige, and a few days later I received, if I can make it sit here, it won't stay. I received this. Basically a pocket reference to the assembly, to the instruction set on the Z80. And it didn't do me any good. I mean, sure, the instructions were explained, but I still didn't understand. I mean, I understood what the book was talking about, but I had no idea how to get those into the machine and make it do stuff. Long story short, finally I found a book that had just come out on Z80 assembly, and that's what really got me into not just computer programming, but into games in general. The first thing we need to do is take the board out and, well, probably go in, check voltages, if the stuff coming in on the harness is okay, and let me get some light and show you the rest of what's inside the cabinet. So there we have the infamous Atari power block. I mean, an early revision, there's very little on it. The later ones, like in Asteroids and following games, were much better populated. But well, that comes out. There's nothing else in here. There's no extra soundboards, extra regulators, nothing. Regulation is all done on the main board. So let's go and check and see if we are getting voltages coming in, and if we are getting proper operating voltages regulated on the board. Now I have a slight suspicion. Well, obviously the board isn't running because that button was lit up permanently. It's the serve button, and it wasn't accepting any credits. So what may be happening here is, usually when this happens and you see something stuck, at least the lights that are on will be full intensity. This light being on in a half-assed fashion seems to imply to me that the 5 volts at least on the board is off, i.e. low, and nothing's running. But yeah, let's see what kind of power is coming into the board and what the board's doing with it. You can see the big power supply there, which houses a 3 amp 5 volt regulator, and it's probably where we'll be doing our work. Next would probably be the monitor, a black and white monitor, a Tech 600. Again, the neckboard lights up, but there's nothing showing on the screen, and turning intensity up and down didn't really do anything. And I couldn't feel high voltage on the screen, but that really doesn't mean anything until we actually go in and check the PCB. Here's the board now on the bench, ready to be tested. One thing I realized when I was bringing this down was, so I was trying to emulate the original Breakout game on my TRS-80 in assembly language. But not until later did I find out, which of course I succeeded at finally doing in assembly, but after a few years when I got my hands on a manual for the Breakout game, to my surprise I saw that it didn't have a microprocessor on it. The original Breakout was completely hardwired. Everything was done in real-time logic, and it is an incredibly interesting thing to look at if, of course, you are interested in digital electronics minus the microprocessor. And I think that book should be used as a textbook in beginning digital college classes. But hey, here's the Super Breakout board. You can see this does have a processor, a Z80 on it, which looks like it still has the original tape securing it to the board. The program code is contained in these small proms, which heat up pretty good. There's space for 24-pin EPROMs here, but it probably needs some rewiring over here to, or this may actually be a jumper block here, to put 27/16s in here, because I mean they've lasted this long. I don't know, well, I don't know if they lasted or not, we'll find out, but if they haven't, I'm going to have to make plans to burn the code into 27/16s and put them in here. I did make sure to check that all of the voltages from the power block were coming in here, and even checked on the board while this was still upstairs in the garage, to make sure that the incoming voltages were good, and they were all good. I mean, there's 10 volts unregulated, which is more like 15 volts coming in DC, and a couple of AC feeds that are rectified and regulated on board. But the main guy I was interested in was the regulator over here, which is an LM323K, which is a 3 amp 5 volt regulator, and they were a little bit cheap on the heatsink here. It does not look to me to sufficiently cool this chip, because it's going to be drawing it's going to be drawing close to 3 amps. But lo and behold, I did some checking again while the game was plugged into its original power supply, and the 5 volts on the board showed 2.4 volts. Well, that looked like a dead giveaway. We either had a short on the somewhere on the board that was shorting the 5-volt rail, or this guy was bad. I was kind of hoping that this guy would be bad because that would make it easier to diagnose. So I checked the resistance on the 5-volt rail, and it was really, really low. It was on the order of like 30 or 40 ohms. So I said, let's see what happens, and I pulled out this guy, and the resistance went up to several hundred ohms. So it looked like this guy was a culprit. Pulled out the regulator, date coded 7752, so he's an old guy, and just doing a diode check. So yeah, this guy is not good. If we do a we can see that even though he's not dead shorted, there's very low resistance there. And that probably would explain why it's still being able to deliver 2.4 volts or whatever on the rail rather than dropping to millivolts. But, yep, he was bad. So he's been replaced. And the next thing I saw was there was a 16-pin audio amplifier here with a big copper heatsink on top of it. Now when I looked at it closely, because of the height of this heatsink, I mean it was sitting at an angle like this. It looks like doing storage or doing whatever of this board, it got caught on something, and when somebody yanked it out, it pretty much pulled the chip apart. And so it actually broke the chip in half, and all of the bond wires were out in the open. So I replaced this one. Well, I took this one out. It's a TDA, I think it's a TDA 1004. Can't read that anymore. I'll look it up in the schematic, but yeah, I need to order a replacement for this. I don't have one. And it'll just go right back in here, and the heatsink came off, so I got to get some thermal glue and put the heatsink back on, and then it's time to go and test the board again. Alright, we're back with the game. I hooked it up. And those alligator clips you see on there are the result of me being a total optimist. What I did, since the power amp's gone, I did hook up a small powered speaker, the white one, next to the light there. And let's see what happens if we turn things on now. Okay. Nothing here. Does it coin up? Yes, it does. And The monitor is showing something too. But the camera doesn't show this very well. It's kind of weird. The text doesn't show up well. It's showing a little blooming. I mean, it looks sharper on the camera than it is in real life. And the focus control doesn't do a whole lot here. So something needs to happen with that monitor. But it just really doesn't look very good. Amazing how good it looks to the camera. It looks about 5 times as bad in real life. But we were able to coin up. So let's start a game. And the serve button is blinking. So I'm going to try to play it like this. I'll put it on cavity mode and press the serve button. So the game's playing, as you can see. But the monitor needs some work. So we are that much closer. And let's put it into test mode, see if it complains about anything. Where is the test switch? There it is. So I don't know what that means, but you can see the number there. It shows the position of the paddle, and it's kind of fidgety. I mean, I cleaned it with contact cleaner already. Now, the manual doesn't really give me a clue as to what this means, because it's supposed to be performing a bunch of RAM-ROM tests and display the results on the screen, but since it's displaying nothing and going straight to the paddle display, I think that means everything passed. So what we can do at this point is test the switches. So every switch you hit should emit a sound, which that does. That makes little blips. Those work. And next, the coin switches. And the slam switch. All right. So it seems that the game is a go. Get it out of test mode. And we get back our ugly display. And it's not that the overlay's dirty, it just, I don't know. The fact that I cannot adjust the focus properly, I mean, I get very little change, but that's not normal on them. So I guess now the monitor needs to go on the bench, and we need to check some voltages and other stuff. I brought the tube into the lab, well, the whole assembly actually, and pretty much took off everything that was between the tube glass and the player's eyes. One is the colored overlay, and then on top of that there's also a smoked piece of acrylic. Now I think what you can see, I tried to get a good angle on this, that there's some pretty severe screen burn in here. You can see all the bricks over here, you can see the border, and the text down here, which is kind of smeared because I guess voltage has changed over the life of the monitor and the position's changed. This is not, I mean, it's moderate to severe burn-in, but you can't really see it when the tube is on. but I cleaned up everything. A lot of dirt came off it. So let us have a look at what I was able to do with the electronics. So I went in there and I mean, a problem like that where, you know, focus isn't adjustable and just things on the screen don't look right. They look unclear or washed out or whatever. It's generally not a capacitor problem, but rather a voltage problem. So the first thing I did was I checked all of the voltage references from the schematic on this board, while it was on, of course, and wouldn't you believe it, all of the voltages, they were right on. I mean, they weren't even off a few percent. They were pretty much what the schematic said. And so if the voltages are good, if the ripple is good, I mean, if the ripple was bad, that would point to capacitors, but all of that seemed okay. So anyway, I went in, I pulled all of the electrolytics and tested them off board, and they were all pretty good. There was some drifting in values, nothing serious, and the ESR tested good in every single one I pulled. Then just for grins, I went in, I checked diodes, transistors, in circuit, any suspicious and non-suspicious looking resistors. I couldn't find anything in there, and it wasn't a big surprise to me because, again, a problem of this nature usually points to the CRT tube itself. And that's what seems to be the problem. One dead giveaway on this monitor is that when you turn it on, it takes an abnormally long time for an image to appear. Now, the time it takes for an image to appear is directly proportional to the cathode in the CRT, the cathode temperature. And that's why we have a heater that heats the cathode, and when the cathode reaches operating voltage, it starts happily emitting lots of things, and then you get a picture on the screen. But if that takes a really long time, either your heater voltage is low, or the cathode itself has lost emission capabilities, and it cannot be permanently fixed. I mean, think of the CRT as an electron tube, and you can't go inside and replace anything in there. So the way the cathode is heated is, it's generally on monochromatic CRTs, it gets a 6.3 volt AC input, and that's what actually just runs through heater wires that are basically surrounding the cathode with no direct contact, of course, and that's supposed to bring up the cathode to normal operating temperature. But from reading up on this, there's two temporary measures you can take to marginally increase the performance. One is to slightly increase the heater voltage coming through here by a few percent, and that may buy you better focus and better definition of the picture. In this case, the heater voltage comes straight from the main transformer tap, which is over here, and there's no resistors in there. There's nothing in there I can use to boost that voltage to the CRT. So one other thing you can do is it's kind of like a rejuvenation, but that is you run a higher cathode voltage into this unit for a short amount of time, and that may get the emissions dancing again on this. And on this particular one, it wasn't that difficult because conveniently it's got a connector just for the heater voltage. So I disconnected this, I soldered on two wires directly to the neck board, and using my variac, I set the variac to 10 volts AC, the TV was off, and I basically fed 10 volts AC into this for about half an hour. And I never tried this before, but supposedly it does do some rejuvenation. However, any increase in the heater voltage is going to shorten the life of the tube because the heater wires are going to burn out that much faster, just like an incandescent lamp. Long story short, I gave it about a half hour of 10 volts AC. It was a bit scary because the neck really lit up brightly when I did 10 volts, and that's not even twice as much, because the nominal voltage on this is supposed to be 6.3 volts, but it was already at 6.8 volts. But, you know, what do I have to lose? I mean, the way the tube displayed, it was unusable to me. So I jolted it for about 10 minutes, and I think it made a slight improvement. And maybe it improved it enough to to make it workable until I can come. I mean, I need a replacement tube for this. And if this were a few years ago, all I had to do is go to the landfill, and there'd probably be gazillions of 19-inch black and white TVs in there, and I could find a tube. But now they're getting kind of rare. They're not just floating around anymore. So I figured either I'll blow up the tube or I'll make it acceptable for now, since as long as this is in my collection, it's not going to be on 24/7. And maybe I'll get good life out of this, or at least while I'm waiting to source another tube. So on this, as I mentioned, all the voltages were good, and even the anode voltage on this, which is supposed to be 18 kilovolts, was like 17.8 kilovolts. So the chassis itself is operating correctly. And if I had a new tube, it would be plug and play. But anyway, what I'm testing this with right now is, I didn't want to bench power the Super Breakout board here. So what I have is an Atari Flashback 1, one of the small, recent releases. And let me go and turn that on. It is connected to the TV. The TV is on. I turned it on so it would warm up. And here's what we get. It's much more readable than it was before. I don't have any video of it, of having that thing hooked up before I gave it the rejuvenation, but the focus is cranked up all the way. And also keep in mind that what you're looking at it's a color composite output fed into this, and that isn't going to show it off really well. Everything that's dark like this is a different color or has reduced colors in it. And there's also a bunch of lines here. I don't know if you can see them, but that's also from the source, which puts different color gradients all over the place. So this is not a final test of it, but you can read what's on the screen. At least I can. And it actually does look, this time it looks better in real life than it looks on the camera. But what we need to do is put this back in the machine and have it driven by the by the Super Breakout board, and see if we get an acceptable image out of it, and then start putting the color overlay and the smoked plexi on top of it, and see if that gives us a good enough picture. Another interesting point to note is that this monitor has definitely been worked on. I mean, I couldn't see any parts replacement, or when you look at the PCB, or new looking parts without dust on them. But what I did find is when you pull off the neck board, there's supposed to be a plastic shroud over here that has the key that matches this. Oh, the key that matches this indent over here, and that's gone. So the problem with that is this neck board will go in almost any orientation. So you have to be very careful, and fortunately I paid attention, and the way to do this is you make sure that the writing is aligned with the horizontal of the tube. So this resistor designator needs to be in this orientation. All of the writing needs to be basically match the tube orientation, and that's the correct way to do it. But again, because that shroud and the guide pin is missing, or the guide notch or pin or protrusion, this can be plugged in any orientation. And I wonder if somebody pulled this thing out to figure out why the tube was weak and pulled that thing out and never put it back. Mysteries, mysteries. But let me remove the rejuvenation wire, put the insulator back on again, and hook it up to the machine finally. So now let's add the overlays on the monitor and see what the final result looks like. First, the colored gel. Let's see from a player's angle. That's about right here. I have to adjust it. I have to get some more heavy-duty two-sided tape to attach this. Is it here or is it here? I don't know. I'd have to look at a picture. I don't know if the blue bar is supposed to go over the text or the paddle. Well, we'll find out. But that's number one, and number two is the smoke plexi overlay. Still looks pretty good. And here it is. Here's what it's going to look like. It's not ideal, but it's not too bad either. What do you think? Maybe if you play a partial game, we get a better impression. Okay, let's coin it up and what do you want to play? Progressive, cavity, or double? Double? Sure. No, actually I don't like double because it has two paddles and it gets really confusing. Let's play progressive. Ready to go. Yeah, I'm not sure. I think the paddle's supposed to be where the blue bar is. I don't know. I have to check pictures. I don't know the exact location of the color overlay. But, you know. So right now, remember, the paddle is right above the blue strip. Come on, at least one breakthrough. Oh! Well, there's a breakout. We did break out. Okay. You may have noticed that the paddle moves pretty smoothly. I did go in and I tried cleaning the original, but it it's a 5K linear resistor. I just swapped the pot out, and it works perfectly. So we're good here, and once I got this put back together permanently, we have to start on the part of this that excites me a little less, and that's cosmetic issues. She doesn't look too bad. One of the things I'll probably do is there's still a fluorescent tube on top behind the marquee, and it gets pretty hot. It's actually started spider webbing the marquee, which is plastic, so I'll probably replace that with a modern LCD strip. It's got, I think I pointed out, several dings and dirt all over the place, and some parts that need to be filled, but I think what we'll do is we'll do that in the next episode. The only electrical issue remaining is obviously the onboard audio amplifier doesn't work. I have parts on order for that, including a cap rebuild kit for the monitor. And so when that stuff comes in, we'll continue and make her look as good as we can. Is that neck glowing brighter now than it did before, am I imagining? Oh well. Either way, I think the screen's acceptable now. Thanks so much for watching, and a thumbs up would be appreciated. Subscribe if you want to see the very exciting part 2 of this. And as usual, leave me comments. We'll see you when we're ready to pretty her up.